A really big part of chapter 4 in our textbook is learning about linear patterns. And really, this is just a main focus in Algebra 1 is understanding patterns, and especially linear patterns. And so, what we've been learning in class is that a linear pattern can be represented by a graph, and the word linear up here really reminds us that we're just talking about a line. So let's make up a linear pattern down here on this blank graph. Let's say we have a graph that starts at the point 3 on the y-axis. So 3 is going to be kind of my starting dot on the graph here, and I'm going to put a little point right here at 3. And let's say we have a pattern that's growing maybe up by 2. So we're going to go up 2 squares over 1, up 2 squares over 1, up 2 squares over 1. And we're going to design or make a line that goes through these points. So something going in this direction, try and make this work, and also pointing in the downwards direction. And this line is totally linear, well, mainly because it's a line, but also because it has a constant growth number, a growth of up 2 over 1. So we say a growth of 2. And that constant growth number, because it goes, I can even make a little triangle on here, because it goes up 2 over 1 on the graph, and the growth never changes, it's always 2, that's how I know it's a linear pattern. So we know that it starts at 3 here, and goes up 2 over 1, up 2 over 1. So, in this chapter, in chapter 4, this is kind of the 4 different ways we're going to study linear patterns. Whenever I'm talking about linear, I know I can represent a linear graph or a linear function as a graph, as an equation, as a table, and as a pattern. And so these are the 4 things that are going to interconnect. We sometimes call this a web in class, the web of patterns here, all connected to linear. And so I could do something like give you a pattern. Here's a pattern that's all made up. Has 3 pictures. We called it figure 0, figure 1, and figure 2. And I can tell by studying this pattern whether or not it's linear. It all depends on its growth. If the growth has a constant number and it's growing by the same amount. So here in figure 0, we have 2 squares. So we can see those 2 squares pretty easily. Well, those same 2 squares are right here. So, if I asked you how much did this pattern grow by, how much did we go up by, you'd say, well, it looks like there's 1, 2, 3 extra tiles or 3 extra squares added to the pattern. So it looks like we went up 3 tiles. So now we go on to the next picture. Here are those 2 same squares from the original figure. Here are those extra 3 that were added on earlier. And now we're talking about adding more. So now we've added 1 to the bottom, 1 to the side, and 1 to the top. Which means we're still going up 3 tiles. So I can see that this pattern, although kind of messy on the screen here, has a growth number of 3. And I'm going to write that down here, a growth equal to 3. And I know when I see this that it's a linear pattern. I can just tell because the growth is constant. Now, if this growth hadn't been this way, if it had gone up 3 tiles, and then maybe like a plus 4 instead of a plus 3, maybe it had grown 4 tiles or 5 tiles, then the growth wouldn't have been constant, and that would have been a different situation. But this is not the case. This is totally a linear pattern. Here's another way we can study a pattern. We can look at it in a table. And with a table, you have to be very careful to study it closely. Figure 0 in this table is kind of in the center of the table. At figure 0, there are 7 tiles. So what I'm going to focus on is noticing what the growth number is. What are we doing as we move this direction? And it looks like the growth is going down to minus 2, minus 2, minus 2, minus 2. And so again, this is another example of a constant growth. It's going down 2, down 2, down 2. So I'm going to write here the growth equals negative 2. So this has got to be a linear pattern because the growth never changes. Now, if it had gone down minus 2 and then it had gone minus 3 and a -4 and a -5 or something weird like that, then I would have said, whoa, that's not a linear pattern, that's something else. But that is not the case. One way we can show a linear pattern is by going straight to what we call the rule in class, and that's just the equation for the line. And so when I see this, I think of the whole old-fashioned y equals mx plus b. Mx plus b is a linear rule or a linear equation. In this case, m is 5 and b is -1, and that is what we call our growth and our start number. I can tell when I look at this rule that 5x represents the mx, and that's your growth number. So when I talk about growth, I can see from this rule that the growth is equal to 5. That means if I was to make a table, let's do that here. Let's make an XY table for this pattern. This is a table that is growing 5. So we're going to set up our little table here, and I apologize, it's a little messy. But let's start it with figure 0 and go figure 1, figure 2, figure 3. Well, the starting number comes from the b, so in this case it's a -1 that we're looking at here, which means in my table, my start number is going to be at -1. My growth number looks like it's a 5x here, so we're growing by 5, which means I'm going to look at the pattern and realize that I have to be going up 5 for each growth. So what's -1 plus 5? Well, that would be +4. And I have to continue that pattern of going up 5 to the next point. So 4 plus 5 is 9. And I'll keep on going in that same pattern, up 5, because it's linear and it's constant, and 9 plus 5 is 14. And I could continue. I could do figure 4, and I could quickly figure out the next number is 19. And then I could do figure 5, figure 6, figure 7, but I don't really need those extra numbers. There is my table. So I guess the big takeaway from this video is to kind of realize, going back here, that whenever we're talking about linear, that word linear, we're referring to 4 different ways. 1 is we can make a table, 2 is we can write an equation, 3 is we can make a graph, and 4 is we could draw a pattern. And no matter which way you choose, 1, 2, 3, or 4 here, every time you go and do it, it has to have a constant growth number. So if we're looking at a pattern like we were here, that growth number, which was down here, the +3, has to stay the same. You have to grow 3 tiles each time. Or that growth number in a table, like in this case it was a -2, -2, -2, -2. It's got to be the same every single time. And if it's in a rule, it's a little different in a rule. Usually the growth number is given to you right there in the mx part of the rule. So I guess the big takeaway is, yeah, we've got 4 ways to represent a linear equation. We have table, equation, graph, and pattern. But on top of that, if it's linear, it's always got to have a constant growth. The growth number doesn't change. If it's +2, then it's got to be +2, +2, +2, +2 the whole way through. That's really important to remember. So keep studying your Chapter 4 targets. We'll keep working on graphing, and we'll work more on tables, but this is kind of a big overview.